Okay, so this call is being recorded. I mean, this class will be recorded. So don't do anything misbehavior. Otherwise, it will be recorded online, and this college authority can take actions against you. So that is why be careful. You have to be totally professional. Okay. So this course is actually named as matrix theory, calculus, and ordinary differential equation. I am Dr. Jagannath Roy, working as an assistant professor in the Department of Mathematics. So, and you can contact me. I prefer email contacts here. If you have any doubt, or you can. Let me discuss about the structure of the course. First, okay, we will start our commencement is today, and the last working day will be on 8th March. So there will be maximum of 42 lectures, and if you complete this course, then you will get 3 credit. So 3 lectures, no tutorial, and no practical also. So it is totally based on lectures. There will be no tutorial. For prerequisite, it is mentioned as nil, but whatever you have learned in class 2 level, so that is sufficient to start with this course. Now, for each course, there are some objectives, there are some outcomes. So what you will learn in this course, that is very important. What you are going to learn over the next 42 lectures within next 12 weeks of classwork in this course. So we will try to solve the consistency of a linear system of equations. Then how to get quadratic forms, congruent forms, finding the maxima and minima for multivariable cases. Already you have seen that for maxima and minima, we try to find out, we make the first derivative as 0, then verify the second derivative, whether it's greater than 0 or less than 0. Based on that, we can try to find out whether it is maxima or minima. But that is for single variable case. That was y was a function of f of x. Now, when we will have functions like this, y equals to f of x1, x2, x3, xn, several variables, then what will be the cases of how to find the maxima and minima in that case. So most of the real life engineering problems are several variable type problems. And then we will learn about the ordinary differential equations with arbitrary order with constant coefficients. And then finally, we will see some aspiring engineering applications of the theory part that we discuss in this course. So these are our 5 objectives, 5 outcomes. Now, regarding the syllabus, so this is tentatively proposed. We will have matrix theory. This is unit 1. Then we will have differential calculus. This is unit 2. And then we have coordinate differential equations. So this is unit 3. Okay. Now for a reference book, you can follow either this one or this one. No single book is actually is perfect. So I will collect from all the books to prepare my class notes so that you can have access, but it is better to follow or better to solve the problems. Although this PDF copy is not there, but you can also work on this PDF copy. All the PDF copy are there. For practice problems, you can solve the exercises for practice purpose. Any one of the 5 textbooks to solve the exercises. Okay. Now there are these are the lectures schedule. So we will try to cover this matrix theory within 14 lectures. Then also this differential calculus within 14 lectures. Finally, ordinary differential again 14 lectures. So this is more or less overall idea. But since this is tentative, sometimes it can take more time also or less time also. So depending on the situation, we will. But yeah, apart from this, so this is from this academic year, we are implementing the new education policy. So in that case, so we are actually relaxing the burden of exams, but it will be continuous evaluation. Okay. So 60% will be internal marks. Out of 100, 60 marks will be, it can, whatever, maybe 200, one can take 200 also. And then they will normalize up to 100. But that is a special case, but we will talk about only out of 100. Okay. For 60% will be internal. For internal is divided into 3 parts. One is called minor, one is called midterm, another is minor 2. Or you can call it a quiz, assignment, or minor, anything. Okay. So this will, depending on the situation, we will work on it. And then traditional exam will be 40% marks. So traditional, this is as usual, whatever you write after say semesters. So this will be. And now, since this is a very short time, yes, everything I will share. This PPT and other things and scheme, everything I will share. Okay. This lecture notes. Yeah. So these are the instructions. So evaluation will be continuous. Okay. And then after 12 weeks, there will be completion of the semester. Yes, marking, ultimately it is absolute. Marking will be relative, yes. As per the institute guidelines, marking will be relative. Yes, yes. Okay. Of course, sometimes without disturbing the classwork, we have to take the minor classwork, class tests. So minors are like class tests. Okay. But for midterm, it is as per the instructions, we have to take at least 20 marks. will be descriptive type. Questions. You can also, one can have the freedom to make it 30 also. So 30 out of 30 can be descriptive type. But this final exam will be descriptive. This minor ones can be MCQ type, or it can if it can be presentation type also, depending on the subject. But for mathematics, there is no presentation. We have to solve problems. Otherwise, the idea or concepts are not clear. Okay. So let us start with the topic, that is matrix theory. Okay. Before we start, let us just recall the concepts of scalar and vectors. Okay. So if you remember that vectors, geometric vectors, what we did, it has a magnitude, it has a direction, right? But we can have, so this is maybe you can think about it. It is a two-dimensional vector. In 2D. You can have also three-dimensional vectors. Okay. Now, if what will happen, what are the vectors in higher dimension? Maybe 4 dimension, 5 dimension, or higher dimension, and etc. We can draw up to 3 dimension. We can visualize up to 3 dimension. More than that, we cannot do. So after this 3 dimension, what we have to do? Everything we need to work on abstract sense. For example, suppose x is a vector 1i plus 2j. Y can be a vector 3i minus 2k or 2j plus 5k. Okay. Then what we do, this vector can also be represented in physics. You will have always a vector of having magnitude and direction. But in mathematics, what we do, because we have to study in higher dimension cases, so we have to use abstract sense. Abstract. What we'll do is x will write 1, 2, and y we will write this x vector 3 minus 2 and then 5. Similarly, if we have a vector of, suppose this x vector is actually of this form, for example, a1 x1 plus a2 x2 direction and plus an xn. Okay. Then x is a vector. We will write A1, A2, AN. So this is a vector also. So in a abstraction, because we have to study, most of the real life problems are multivariable cases. So there are variables. X1 is a variable, X2 is variable, Xn is a variable. Like here, I is a variable, J is variable. Here we have three variables. Okay. Now, roughly speaking, from the abstract mathematical viewpoint, any object that satisfies the following two properties can be considered as vector. See, vectors are special objects that can be added together. Suppose X is a vector and Y is a vector. Then we can, if X and Y are vectors, then this X we can have can be defined. Now if lambda is a scalar or a constant value, then the multiplication, if you scale it, scale means either lambda greater than 0 or lambda less than 0. The scaling property is also multiplied by scale. So that means lambda times x can also be defined. Remember, this addition is also a vector. And this multiplied by a scalar is also a vector. So that means there are objects for which you can add them and you can scale them. If lambda is less than lambda is half, then it is reduced. The size of the vector will be reduced. Okay, for example, for computer scientists, vectors are the arrays because they will add some arrays x1, x2, xn, one array, another array, one, y2. So the same concept, vector is a concept. Physics, it has magnitude and direction. For computer scientists, they will say array, geometric vectors. Okay, but for mathematicians, in mathematics, vectors are the quantities that can be, these are objects that can satisfy these two properties. Okay. Any object, it is writing any object. So that means, because we are generalizing the concept, now these vectors are very closely related to the matrix. Okay. Suppose this is a m by n matrix. Now if you collect all the rows, and also if you collect all the columns, then you will get another two types of vector, because what we have seen, vector means it is a of this form. Suppose A1 is A11, A21, AM1, A2 is of this form, A12, A22, AM2. Similarly, AM, A1, this is N. Okay. So this is again, we have now from this row or column vectors using these concepts, what we can get? Now, if you write this vector as A11 into x1, some unit vector A21 plus x2 vector plus and so on, and this one is M1 xm of this form. Suppose these are unit vectors, x1, x2, xm are unit vectors. Then this is a vector compared, if you remember, yeah, this one. So this is, if you write it horizontally, so we call it a row vector. And then if you write it vertically, then you will get a column vector. So these are very close to a row and column of a matrix. Similarly, if you remember, if you can see that B1 is A11, A12, A1n, B2 is A21, A22, A2n. Similarly, M. So these are row vectors and these are called column vectors. This A1, A2, An are called column vectors. Okay. Now, if you remember the geometric vectors we have already seen. Okay. The applications of vectors you can see. Since you are in ECE department, maybe you will work on audio signal processing and others. Then you will see that you can relate the concept of vectors in this case. So audio signals may be of this form. Okay, of this form. Then from these audio signals, you will get another audio signals after decoding these audio signals. Okay, these audio signals. So this can be treated as a vectors. A11, A12, and so on. And the resultant can be C11, C12. Like if you consider them as a vectors, then you can add them. Otherwise, not. Remember, vectors are any objects that can be added and can be multiplied. Okay. Now, if you remember this auto-tuning feature, they actually use the scaling factor. This is a audio signal. It is multiplied by lambda. That means it will increase the volume or decrease the volume. So that type of applications can be seen. So this is most important in mathematics. That is, what is the symbol? This n tuples. That means the elements if we have x as a x1 and x2, then we call it a member of R2, then two dimension. If we have x as a x1, x2, and x3. Then we call it a member of R3. So 3-dimension. Similarly, if we have x equals to x1, x2, xn, that belongs to Rn. So n dimension. N is an integer, a positive integer in dimension. Now a vector in R3 will look like of this form. Either you can write it as a row or you can write it as a column. Now if you have another vector, for example, 2, 3, 4, we call it a y. So this is also a member of R3. Okay. Then since they are vectors, so you can add them. That means if you add them, x plus y, so you will get component wise you will add 1 plus 2. So this is 3. 2 plus 3. So this becomes 5. Then 3 plus 6. 3 plus 4. So this becomes 7. You say this is also a vector in R3. So with the help of two vectors, we get another new vector. Also, if you write 2 times x or minus 2 times x, so you will get, when we are in the mathematics, we don't have to put this arrow symbol. When the concept is clear, then you can directly write. So minus 2 times this one, 1, 2, 3. So this becomes minus 2, minus 4, minus 6. Again, this is also a member of R3. So if you scale it, if you multiply with some scalar, okay, maybe it is positive or negative. Okay. Then we get another vector. Anyone?
For different dimensions, we can't add the vectors.
Yes. So different dimensions. I'll tell you the next topic. I was going to mention. Suppose you have x equals to a two-dimensional vector 1, 2. But if you have another vector 1, 2, 3, so this is a member of R2. This is a member of R3. So x plus y, this cannot be done. Is x plus y is not possible. It is like asking that suppose you have 2 mangoes, okay, plus 3 apples. How many apples? It just look like how many apples. So this addition cannot be done. Similarly, vectors can be similar. Will have same dimension. Okay. So this is not possible. Similarly, this is not possible. Now there is a concept called linear combination. Okay. So linear combination is that if we have a vector v1, v2, and vn, n different vectors, we are not talking about what is the dimension. I mean, in which space? They are just vectors, n different vectors. Okay. In the there is called something called vector space. For example, if you don't know this concept, this what is vector space, don't worry. For vectors, you can see that either it is a row vector or column vector. whenever I say vectors, then you should understand this, either it is a row vector or column vector. You don't have to bother about this vector space. Okay. Then we can call it another vector. Since we have seen that if we add them, we get a new vector. So if we add all the n different vectors, then we get another new vector, which is called a linear combination of these n vectors. For example, if we have v1, v2, and v3, let me write v3. Two-dimensional vectors. Then if you add them with some, say this is real numbers, c1, c2, and c3. All these are real numbers. For example, real numbers. Okay. Then you put any 3, minus 7, and 0 and take the combination. Okay. So this is a linear combination. So this is again a vector in R2. So 2 comma minus 28 is a linear combination of this thing. Now the question is, how many linear combination can be done with these three vectors? The answer is infinite. If you change in place of 3, you can take 4, you can take 5. In place of minus 7, you can take 7, 6, and other things. For 0, for 1, 2, you can take all this. So there are infinite number of combinations. We can have linear combinations. But if suppose you take squares, then it is not linear combination. Okay. We have to take all the power of this vectors will be 1. So this linear combination. In fact, v square is not valid. V1 square, vector 1 square is not valid till now. We can define it later, but as of now, it is not valid so far. In this course. Now, there is a concept called linear independence and dependent. Suppose we have vectors, n vectors are there, x1, x2, dot, dot, xn are vectors. You take the linear combination. Just now we have seen the linear combination. This one. And make it 0. Okay. If this equation gives you the solution that all the constants are 0, then we call it a linearly independent. Otherwise, it is dependent. There are no third possibility. That dependent plus independent, that is not possible. So either it is dependent or it is independent. So there is only 2 possibilities. For example, if you take x1, 1, 0, 0, x2, let us consider the trivial case, 0, 1, 0, and x3 is 0, 0, 1. So all are vectors of R3. So let us consider constant C1, or let us write K1. K1 times x1 plus, take the linear combination, K2 times x2 plus K3 times x3 becomes 0. Now when we talk about this 0, that means it is also a member of R3. Okay. Again it becomes, if we add 3 apple, you cannot get some mangoes. So that is why this dimension should match the right hand side and the right hand side dimension and the left hand side dimension should match. That means K1 times 100 plus K2 times 010 plus K3 times 001, and the right hand side will become now 000. Zero vector is when 0 belongs to this R3, that means we will write as a 3 zeros. When it is R2, then we have 2 zeros. You have to understand this concept. Now, if you multiply and simplify these equations, then you will get K1 times 1. So this is K1 plus 0 times K2, 0 plus 0 times K3, 0, and the right hand side becomes 0. Component wise, we'll do the multiplication and addition. So then 0 plus K2 plus 0 becomes 0. 0 plus 0 plus K3 becomes 0. So after solving these three, what we get? K1, K2 and K3 all are 0. So it satisfies this definition that all the K1, K2, K3 are 0. So what we can say that this is linearly independent. This x1, this implies x1, x2 and x3. This set of vectors is linearly independent. Now there may be a case where suppose x1 equals to 1, 2 and x2 becomes 2, 4. Now if you define k1 x1 plus k2 x2 equals to 0, then what happens? K1 into 1, 2 plus K2 into 2, 4 equals to 0, 0. So you will get here K1 plus 2 K2 equals to 0, and then 2 K1 plus 4 K2 equals to 0. If you solve them, what you will get? In fact, this equation and this equation are, same equation, just a multiplication. There is a multiplication of 2. So you will get 2K2, or let us just write K1 equals to minus 2K2. So this system of equations are not solvable. So if you want to get solution, then what happens? If K2 equals to 1, then K1 becomes minus 2. So the condition that we have seen previously, that all the Ki's should be 0, then linearly dependent. If it is not happening, that means at least if, that is, at least one Ki is non-zero, then linearly dependent. So that's the definition of linear dependence and independence. Okay. Now it becomes very difficult if we have a system, for example, 20 equations and 20 variables. Then how to check whether it is dependent or independent? Okay. So this is already done. I'll let you this task. Verify verify whether these vectors are linearly dependent or independent. Now, since this is actually three variables, so it becomes very easy to calculate. For example, k1 times 1 1 1 plus k2 times 2 minus 1 4 plus k3. So vectors here a, b, and c.
Sir, they are linearly dependent, sir.
Yes, yes, they will be linearly dependent. So 5 to 7. With okay, the right hand side will be 0 0 0. Now find out k1, k2, and k3. If all of them are 0, then independent. If at least one is non-zero, then it becomes dependent. So somebody has already solved and he is telling that they are linearly dependent. So try to verify this result. Now, since this is a 3 by 3 system, so you have three variables, k1, k2, and k3, and three equations. So it is easy to solve for hand calculation. But if it is a higher dimension, then what we will do? Then we have to use a strong theorem. That is a strong tool that is called theorem. So if you have n-dimensional vectors, so P1 is a vector of n dimension, P1, P2, and Pn belongs to n dimension, all these n vectors. Then this theorem says if they are linearly independent, then the determinant, how do we write? This determinant write as a vector. Sorry, this B1 vector, write it as a row vector, as a row of the determinant. And the vector 2, you write it as a second row of the determinant of the matrix. And then take the determinant. If the determinant is non-zero, then we can call it a linearly independent. Otherwise, if this determinant is non-zero, then if this determinant is given and nothing vectors are given, okay, vectors are not mentioned, then from this theorem you can conclude that these vectors, these row vectors are independent. So both way it is true. So that is why the sentence in mathematics, it is a very popular sentence. If, or a very popular phrase, if and only if. That means if this happens, then this will happen. Otherwise, if this happens, then the other part will follow. Okay. Now you try to verify this. Now you try to utilize this theorem in the previous case. So what will happen? You write 1 1 1. So 2 minus 1 4. And then 5 2 7. You take the determinant. Verify whether it is 0 or non-zero. If it is 0, then dependent. If it is non-zero, then independent. I mean, this definition, this is from definition. From this definition, we have this situation. But it will be difficult to find out this kind of situation when we have 20 or higher dimensions, 20 or many hundred variables may be there. So that times, even for determinant also, for 100 variables is not possible to evaluate. If it is a 100 by 100 determinant, okay, then we have to take the computer simulation help. Hand calculation is possible maybe up to 4 by 4. But if it is 100 by 100 times determinant, then we have to go for computer simulation.
Sir, what if the number of dimensions and vectors are different?
Number of vectors and the dimension are different.
Yes, sir.
Okay. For example, what I don't remember, if you have n, so this is n dimension, and you are telling about if n plus 1, right? If you collect n plus 1 vectors,
Yes, sir. But they each have n dimensions.
yes, each have n dimension, but number of vectors are n plus 1.
Yes, sir.
Actually, there is another theorem which is not, I'll mention just, and then, for example, if we have Rn in dimensional space, and n plus 1 vectors, and for example p1, p2, pn of R T, pn plus 1, n plus 1 vectors. Then this vectors are linearly dependent. Because in that case, you cannot define that this determinant cannot be defined, right? Determinant is for a square matrix. But in fact, this is not a part of your syllabus. This theorem is very important theorem which we teach in mathematics, MSc in mathematics graduates. Okay, so for them, if the dimension is n, and if you have n plus 1 vectors, then this number of vectors will be linearly dependent. In fact, linearly independent, the size of the linearly, I can tell you that size of the linearly, for example, this is a collection of set let us call S as a collection of vectors. Okay, size of S, the number of elements of S, let us number of S will be, sorry, let me rephrase. This S will be, S can be, S is linearly independent if the number of elements is less than or equal to n. That means the cardinality. You remember cardinality? I hope you know the cardinality of a set. Cardinal. Or let me just write. That is number of elements in S is less than n. More than that, the set will be linearly dependent. But it can happen that in 1 0 0 and 0 1 0 in R3, these two are linearly independent, but only two variables. Even 0 0 1 is also independent, so three variables. But if you add one more vector 1 2 3, okay, if you try to verify whether they are independent or not, then this set is definitely going to be dependent because it has, so 1 0 0 0 1, sorry, 0 1 0 and 0 0 1 1 2 3. So if you have in R3, then whether this set collection of vectors is one, S is whether S is, I mean, it is saying that the set is independent. That means these vectors are independent. There are two ways to say this event. The vectors are independent or the set is independent. Okay, whether S is independent, linearly independent or linearly dependent. If you know this the previous theorem, this theorem, then you can directly say that answer is no. Why? Linearly dependent means, for example, if you remember 1 2 and 2 4, we have these vectors. Suppose these two vectors, if you consider v1 and v2 2 4, okay, what you can see that v2 is a 2 times of v1. So if you take here v1 2 v1 minus, so or plus minus 1 into v2 equals to 0. So this is a linear combination. So whenever they are dependent, okay, that means at least one Ci, Ki, K1 and K2 are non-zero. If you remember the definition previously. So whenever they are dependent, then one vector can be written as a in terms of the other vector. Okay. Now, if you remember, if you consider this example, 1 0 0 plus 0 1 0 plus 0 0 1. So we have a 3 vector, and then the right hand side 1 2 3. So how can you get, if you multiply by 1, if you multiply by 2, and if you multiply by 3, then the right hand side becomes 1 2 3. Okay, now if you collect this vector, this S, if you take it in the left hand side, okay, then what will happen? This minus 1, or you can say minus or plus, so this becomes 0. So if you remember k1 x1 plus k2 x2 plus k3 x3 plus k4 x4 becomes 0. Now if this is this vectors, this x1 x1 x2 x3 and x4 are linearly independent if k1 k2 k3 and k4 all are 0. If at least one ki is non-zero, then x1 x2 x3 and x4 are linearly dependent. So that is, if you remember this theorem, yeah, this theorem says if we have more variables than the dimension of the space, more vectors in the set, then it becomes linearly dependent. Whenever the two vectors are linearly dependent, then we can write one in terms of another vector. They are dependent vectors, we can write in this form. Okay. Now it is your task to verify. So verify this, whether these results are correct or not. Okay. Verify these results as your task. Also verify this is whether they are linearly independent or dependent. So these are for practice problem. Answers are given, so you have to verify whether these answers are correct or not. I'll stop here today, and if you have any doubt, you can ask me.